Hi, this video is on solving a problem of nearest neighbor analysis. This mathematical problem came in UGC-NET July 2018. Usually every year at least one question comes from this topic in UGC-NET, but this one question was kind of hard that students found to solve. So I thought I can help them in solving this question. So before I proceed to the problem and the calculations and everything, I'd like to say two lines on what it is and what the formula is about. So nearest neighbor analysis is basically a cluster analysis tool. With the help of this formula or with the help of this tool, we can conclude if a settlement is clustered or random or dispersed. Dispersed if the value is 2.15, random if the value is 1, and clustered if the value is 0. Okay, so this is the formula where Rn is the index of nearest neighbor analysis, that is DO upon DE. So DO is mean of the sum of the actual distance between the settlements, or you can shortly remember mean of observed distance, and the below DE is the mean of expected distances between the settlements. Okay, so how we can calculate DO? That is very easy. We can take the distance between the settlements and sum them and add them, and then divide the summation with the number of the settlements, and then what we can do, how we can calculate DE, the expected distances. That formula is 1 upon 2 root P. P is density of settlement. Okay, how density of settlement is calculated? N upon A. So what is N? Number of settlements, and A is area. What is area? Area is chosen from topo sheet or a box given in the examination. So in this examination a box like this was given, so from that we can, how can we get the area? By multiplying the width and the length. Okay, and if we calculate from topo sheet, then in topo sheet we make a box like this, and from there we can calculate the area, and the number of settlements we can count from inside. Okay, so number of settlements upon area will give us the density of settlements. Number of settlements over the area will give us the density of settlements. Okay, so from density of settlements we can calculate DE by this formula. Okay, so if we get DE, then by doing DO upon DE we can get the nearest neighbor analysis. Okay, so we will now proceed to the mathematics directly. Okay, so this was the problem that was given in UGC-NET July 2018. This problem asks for the correct Rn value for this settlement, and we have to choose from these 4 options, 1, 2, 3, 4. So let us start with the calculation, and we will do the calculation with the help of these 3 formulas, Rn, DE and P, and we will start with calculating DO. And for our help we have marked these settlements as A, B, C, D. We have marked them, and let's start with calculating DO. So what is DO? During calculating DO we will consider every settlement, like the distance from A, then the distance from B, then the distance from C, like this. Okay, so what is the distance from A? That is, distance from A is 1, and just like that distance from B is 1, then distance from C is 1.2, and then distance from D, the shortest distance we can consider, the shortest distance from D is 1 kilometer, so it will be 1, and then the shortest distance from
E. You will ask that find out F. It will not be F because it is 2 kilometer. The shortest distance from E will be 1 kilometer, that is from D. So we will add 1, and then the shortest distance from F is 2 kilometers. This, so we will add 2, and then we will divide it by 6 because we have 6 numbers of settlements A, B, C, D, E and F, and this gives the values this as 7.2 divided by 6. Okay, and the result is 1.2. Alright, so we got the mean of observed distances. Now we will calculate DE, and for DE we have to know what is the P. So we will start calculating P. P is number of settlements over the area. Okay, so number of settlements we have 6, and over the area is 7 kilometer by 5 kilometer. This is given in the exam. Otherwise, when we do in topo sheet, we select an area and measure it with scales. And also when we do in topo sheet, this distance means the distance between the settlements are also means scaled with ruler. So here we have 5 into 7 kilometer, that is 35 is the 35 square kilometer is the area. We won't write the unit here, we don't need it. So this value comes to be 0 1 7 1 4 2 8 5 7 1. Sorry for this writing because I am writing from my laptop touchpad and I don't have any stylus, so excuse my writing. And this we can trim down to 0.17. We are rounding off to the 2 digits after decimal, so this will be the value. We can calculate with both the full value and the rounded off values, and the result comes almost same. I will show you that later. So let us go with the full value. Okay, so with the full value we will get the root of P. Okay, and let us calculate that, and the full value comes as rounded off value, then it comes as something like, wait a minute, it comes as 0.41. okay, 4, I have rounded it off as well, but this rounded off value gives 0.41. So now we will calculate with this total value and this rounded off value as well. Now we will calculate 2 root P. Okay, do this with the rounded off value, then we get 0.82. okay, again we will calculate with both the values. So next step will be, so we have got 2 root P, so we can calculate DE now very easily. So DE will be 1 over 2 root P, and the value with the full value is, and with the rounded off value we get somewhat 1.22. okay, Now that we have got DO, which is 1.2, and now that we have got DE with these two values, we can calculate Rn very easily. So Rn will be DO upon DE, and that is, and by calculating with this rounded off value we get, you can see the values in calculator, you can follow that. So lastly, what we get with the full digit, we get 0.99, and with the rounded off digit we can get 0.98. Either one we can use, so the answer will be 0.95. That is the right answer of UGC-NET 2018 July. Here is how we can solve this problem. Okay, I'd like to clarify one small thing at the end of this video. That is, the formula for DE that I have used in this video is 1 upon 2 root P, which you can also write as 1 upon 2 root N over A. But over the internet you can find another formula, that is D equal to 0.5 into root over A over N. Okay, this is nothing, just that this formula is derived from this one itself. So now I will show you how it is derived. So firstly, what we are writing is 1 upon 2, excuse my writing all again please, N over A. So if we break this, then we can write this as 1 upon 2 into, or multiplied by, 1 upon root over N upon A. So this 1/2 is 0.5, and the inverse of this thing is root over A upon N. So this is how you get this formula from the initial one. I hope this video helped you in solving this problem. If you want to know how this kind of problems are solved from topo sheet, then let me know in the comment box, and I will make another video to show you how these kind of problems are derived and solved from topo sheet as well. Till then, thank you.